And this is my second draw. And when I pull the ball out of that box, again, I could have white or I could have a black ball. White or black. So those are my little branches. Okay, now we got to come up with the probabilities. Well, remember, on part A, when I did not replace the ball, when I did not put the ball back in, my denominators went down by 1, or my totals went down by 1. Here, it says you put the ball back in the box. So the denominator does not change. We just have 9s still on the bottom. That's different from part A, because part A, our totals on the bottom went down to number 8s. But our ball was put back in the box, so we still always have 9 in the box. Okay, let's see here. If you pulled a white on the first draw, you pulled a white. That means you only have 3 left. I mean, you only have 4 left because we started with 5 and we just pulled 1. So that makes 4. Okay. Whew. Then if you pulled a white, you still have the same amount of black balls in there. You still have 4 black balls. So 4. So our totals are not going down because we put the ball back in the box. The only numbers that are going down are the top numbers, and it's because we pulled that color. So if I pulled a white, the top number on the white probability goes down. And the top number on the black probability does not. So we did that right. Okay, let's keep looking at this black branch. So let's say I pull a black for my first ball. Then I put it back in so the totals stay 9. But if I pull a black, how many whites are still in there? Well, there's 5 that we started with. And if you pull a black, there's still 5 that you started with. Okay? What about if you pull a black, how many blacks are left in there? Well, if there were 4 to start with and you take 1 out, it's just 3. Okay, so this is different from part A. In part A, the bottom numbers changed also. Part B, the bottom numbers do not change because we put that ball back in the box. Okay, let's write all of our outcomes. Let's follow the tree diagram. If I follow this top path, I pull a white and another white. So that's white, white. Let's go back to that first path. I pull a white and then, oh, maybe this black. So that's WB. And then keep going. If we look at this bottom branch and I pull a black first, then a white, that makes BW. And then lastly, I pull a black and then another black. So that makes BB. Okay, let's see what the question was asking for. Find the probability of an event that the 2 balls are of different colors. Okay, so let's find the different colors. WW? Nope, that's not us. WB? Yep, different colors. BW? Yep, different colors. BB? Nope, not different colors. Okay, now let's remember that you multiply along the paths. So to find WB, I'm going to take the probability from the W, 5 over 9. So we're taking WB, and then we're going to look at BW. But for right now, the W is the 5 over 9, and then the B is the 4 over 9. So this first letter, that number comes from the first branch. of this first little guy pulling the ball. Yeah. This second number came from the second branch. Okay, let's look at BW. Well, if I pull black first, not this top branch, this bottom branch, it says 4/9. So 4/9. Then if I pull a white, that's 5/9. And you multiply. So let's see here. This makes 20/81 and 20/81. So these are different outcomes, and we multiplied along the paths. Now we're going to add the probabilities of the different outcomes together. So these two fractions we got, we're going to put a plus sign. Yeah, okay. When you add fractions, the bottoms have to be the same. And on part A, they were the same. And you just add the tops. Let's do it. You add the tops, and the bottoms you keep the same. So we get 40/81. And I don't think you can reduce that, because if you try and divide by 2 or 3, there's no common divisor. So you can't divide that. If they wanted a decimal, you could divide these in your calculator and get like 0.49-ish if they want a decimal. But I don't think they wanted that. Okay, so done with part B. And I put it on the back page. Okay, those tree diagrams are killer. Let's keep going. This next sucker says, assume the probability is 1/2 that a child is born at any time is a boy. And boys and births are independent. What is the probability of the event that if a family has 3 children, no twins, they are all boys? Okay, so this is kind of like, there's a woman, she has a stomach, yeah, the baby pops out, and the baby could either be a boy or a girl. And it's saying that the probability is 1/2. No matter what. Okay, so this is their first child. Then it says, oh wait, there was a second child. Oh no. Okay, and it could have either been a boy or a girl. Well, boy would be 1/2, girl 1/2. And we would do the same thing over and over. Boy of 1/2, girl of 1/2. Then they have a third child. Oh my gosh. And I'm not going to draw all these little baby bumps anymore, but you get the point. So, we have a child, and it could be a boy or girl. From there, we could have another child, and it's a boy or girl. From there, we have another child, and it's a boy or a girl. And every time we have that kid, it's a probability of 1/2 that it's a boy or girl. Okay, so let's figure out what is the probability of an event that if a family has 3 children, they are all boys. So we're looking for boy, boy, boy. Okay, well, if I follow those paths and I start with a boy, I have 1/2. Okay, then what's the probability of having a boy on your second try? Oh, it's still 1/2. And what's the probability of getting a boy on your third try? It's still 1/2. And what are you supposed to do along your paths? Along your paths, you're supposed to multiply along your paths. So we're going to say 1/2 times 1/2 times 1/2. And when you multiply fractions, you go left to right. So this is 1/8. Yay! Okay, again, It says 3 dice are tossed. Okay. So, how many totals? How many total numbers are there on a dice? A dice is that square thing with the little dots on it. Yeah. And it has 6 total numbers that we could put on it. Okay? It says, what is the probability of rolling 3 different numbers? Okay? Well, let's see here. On this last problem, when I was talking about 3 births, I multiplied 3 things. On that whole ball problem stuff, when I was finding the probability, I multiplied 1, 2 things. Yeah, so that's the trick. If you're trying to find the probability of rolling 3 somethings, you're going to multiply 3 somethings together. Kind of like on this last example, we were talking about 3 children. So we had 3 things multiplying together. The 1/2, 1/2, 1/2. Okay? Now we just need to come up with the fractions. Well, totals means the bottom. So 6, 6, 6. Okay? And I want 3 different numbers. Okay? So, how many possible numbers could I roll, or could I toss on that first try? I could toss a 1, 2, 3, 4, 5, 6. Yeah. On that first toss. That's 6 different numbers I could write down. Now it says, what's the probability of rolling different numbers? Okay? Well, if there were 6 possibilities in the first time, let's say I rolled a 6. If I want different numbers for my second roll, that means I can't have that 6 anymore. I can only roll a 1, 2, 3, 4, 5. How many numbers is that? That's only 5 numbers. Well, let's say I rolled that 5 on that roll. How many are left that I could use? 1, 2, 3, 4. And that's only 4 numbers. Okay, so let's go over this again. The bottom numbers came from how many total numbers are on a die, on that little square cube. The reason we have 3 things multiplied is because it says 3 dice, or 3 numbers. That's why we have 3 things multiplied. The totals go on the boxes, okay? Since if it would have said 3 of the same, then we would have had something different. But it doesn't. It has 3 different numbers. So that means there's 6 possible numbers you could put in the first spot, but then only 5 possible in the second, so you don't repeat. Then only 4 possible in the third, so you don't repeat. Okay, so let's multiply left to right. 5 times 6 times 4 is 120. And then on the bottom, 6 times 6 times 6 is 216. But then I think you can reduce by 6 for sure. Let's see what we get. 120 divided by 6 is 20. 216 divided by 6 is 36. Darn it, we can reduce again. Let's go again. Let's try by 4. I think we can get 5 over 9. Yay! So, the probability of rolling 3 different dice is 5 over 9. We multiplied 3 things because of the 3 different dice. Our bottoms were 6s because there's 6 total numbers. Our tops went down because we want different numbers, so we don't want things to repeat. Okay, let's look at this next sucker. It says a date in the month of June is chosen at random. Find the probability of the event of the dates being each of the following. Okay, well first we need to figure out how many total days are in June. And you're welcome, there's 30. Okay, it says find the probability of the event. Okay, so that means 30 is my denominator. And these are 3 different problems, okay? How many days out of 30 does June 3rd happen? It only happens once. Yep, okay, so that's the probability. How many days out of 30 does June 31st happen? Never, because there's only 30 days in June. Okay, well, what did we learn that never means? An impossible event means it'll never happen, and the probability is 0 or 0%. So this one will just be 0, because it'll never happen. Okay, let's look at before June 12th. What numbers are before June 12th? 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, how many days is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Can we reduce? And no, we cannot reduce because 11 is prime. Yay! So when it says before June, it does not mean, or when it says before June 12th, it does not mean the actual 12th. It just means both the numbers before that. Okay, let's keep looking. It says the following box contains 9 letters shown. The letters are drawn one by one without replacement, and the results are recorded in order. Find the probability of the outcome reference. Okay. Well, let's go ahead and write reference out. Okay. For the probability of this outcome, we're going to multiply, kind of like when we did the probability of 3 different dice. We multiplied 3 different children. We multiplied 2 different balls. We multiplied. Yeah. Here we have 1, 2, 3, 4, a bagillion different letters. We're multiplying. Okay, and then we're also going to have fractions. So underneath this is going to be a fraction for everything. So these are supposed to be fraction bars with multiplies in between. Okay, now let's figure out what the total amount of letters is. Well, let's see, total. Let's count these letters in the box. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay, now we need to find the totals of each type of letter. So let's see, for the C, there's only one C in this list. For the E, there's 4. For the F, 1, N, 1, R, 2. Okay, let's go. What's the probability of getting an R to start off with? Well, remember, your total goes on the bottom, 9, okay? How many R's are there? 2, okay. Nice. Okay, so we have no more R's. Now, we have 1 less R, so we only have 1 R left. Let's go to the E's. E's, we do the total on the bottom. Well, if we just used one of our letters, we don't have 9 total anymore. We have 8 total. And if you look at our first example that we did in the set of notes, it says a ball is random and not replaced. Remember that? The denominators went down. That not replaced means without replacement. So in our word problem, we have the words without replacement. That means things are not replaced, and the totals go down by 1 every time. So when we get to the E, there's not 9 tiles anymore, or there's not 9 letters anymore. There's only 8. And then there's 7, 6, 5, 4, 3, 2, 1. Okay? Now let's go through and do the E's, or the actual tops. So my totals go down by 1 every time because it says the letters are not put back in the bag. Okay, this says E. How many E's are there? 4. Okay, the next E is not going to have 4 anymore. It's going to have 3. Where's our next E? Oh, right here, 3. The next E is not going to have 3. It's going to have 2. The next E is not going to have 2. It's going to have 1. So, if I pull out an E for this second spot, there's 1 less, so that's why it goes to 3. Then if I pull an E here, there's 1 less, so that's why it goes to 2. Okay, now let's look at our F's. How many F's are there? There's only 1 F. What about R? Oh, there were 2, but I pulled 1 over here. So there's just 1 left. Okay, how many N's are there? There's 1. How many C's are there? 1. Okay, now let's find the probability. How do we multiply fractions? Well, we kind of did this. Remember on the 3 dice? We go left to right. So we're going to multiply all these numbers on the bottom and all these numbers on the top. For the top, I got 48. For the bottom, give me a minute. For the bottom, I got 362, 880. And you can actually reduce this by 48. So let's do it. So to get this 48 on top, I multiplied all the top numbers. For that big number on bottom, I multiplied all the bottom numbers. Then you can actually reduce this by 48. If you divide the top by 48, you get 1. If you divide the bottom by 48, you get 7, 5, 6, 0. Hey, that's the probability.